Okay, so today we're going to be talking about something called a mid-segment of a triangle. Okay, and so the essential question we want to be able to answer here is, how are the segments that join the midpoints of a triangle's sides related to the triangle's sides? Okay, so a mid-segment, you kind of get an idea. Okay, well, it's going to be a segment. All right, and it's going to have something to do with like the middle. Okay, and what is that? Well, so the mid-segment of a triangle is a line segment, duh, right, it says mid-segment, a line segment that connects the midpoints of two sides of the triangle, okay? Every triangle has three possible mid-segments that you could draw, okay? Mid-segments in like design and construction are often used to add rigidity, okay, to structures to help them kind of, stand and be stable and stuff. For example, okay, if you look at this like picture of a garden swing, I don't know if you guys have ever, this is like a garden swing that's not on someone's porch. It's like a porch swing, but it's out in the the middle of the yard or something like that. You can see that they use a triangle here, designed to help with the structure, and they put this bar across the center to help with the rigidity of the structure. So like when you sit on it, it doesn't bend and fall over and stuff like that. Okay, so that's like adding a little bar there. Okay, it's a mid-segment. You can see that it is roughly, right, this point right here is roughly in the middle of this side, and this point right here is roughly in the middle of this other side right here. Okay, so we could say like, okay, this is congruent to that, and then that is congruent to that. Okay. Now, I just told you guys there are three possible mid-segments, right? You see one of the possible mid-segments right here. If we were to find the midpoint of this third side of the triangle, somewhere about, I'm going to eyeball it right in there, then you can see here's where we could draw the other mid-segment if we wanted to, and here's another mid-segment we could draw as well. So that's why there's three mid-segments there. All right, questions on any of that? Okay. So, turn the page here, and we'll talk about properties of, okay, the mid-segment. Actually, where? 395, 96. Where is it? Oh, okay. So, we're going to skip actually 2 pages, I apologize, to page 398, okay, for some reason. So, page 398, for some reason they wait to deliver this piece of information here. So, the mid-segment of a triangle has kind of 2 properties that we need to keep in mind when we're working with them, okay? The segment joining the midpoints of 2 sides of a triangle, that is the mid-segment, okay, is 1, it's parallel to the third side, okay? The mid-segment is parallel to the other side. So if I flip back to my little porch swing, my garden swing they called it, okay, this mid-segment right here would be parallel to the ground, because that's the other part of the triangle there. It's the ground, okay? So this, the grass right there, okay? So this mid-segment is parallel to the ground because that's the third side it's not touching, okay? This mid-segment right here will be parallel to this side, that like bar, and this mid-segment right here will be parallel to this side, the bar right there. The base is parallel to this mid-segment right here, that one. So each side is parallel to one of the mid-segments. And, okay, here's second property, its length is half of that side. Its length is half of that side. So, in other words, okay, if we built this in real life, right, the length of this bar is exactly half the length of this, the base. From the bottom of the one pole to the bottom of the pole, that length, if you take half of that, is this right here. Okay? And you can kind of see it. How do you think, just, you can kind of conjecture here, how do you think this triangle is related to this triangle right here?
They are congruent.
They're congruent. And how do you think this triangle is related to this triangle right here?
They're congruent.
They're congruent as well. So you can see that this base would match to this base and to this base right here. So you can see there's 1 here, there's 1, 2 there, and they get the total. Okay? So there's congruent triangles there that kind of help you figure that out. All right? So, let's actually utilize that here. Let's look at triangle RST. Okay, you can see it drawn right here. And we're not told this, but I think we're going to have to assume that, yeah, UV is a mid-segment. Okay, and also UW is also a mid-segment. Okay, we have to assume that. They should have told us that. Okay, but they didn't.
Well, this is UW, the length of the big segment UW.
I know, but it's still like they didn't identify, which is weird. They should have, because right now we are just having to assume it. So anyway, okay. So let's take a look at this. So the first thing we're asked to do in this triangle is to use this triangle to identify the length of UW. Okay. So here's UW right here. Okay, and it's a mid-segment. All right, so that means it's parallel to what side here? So I'm going to raise your hand and tell me UW must be parallel to what side? Debbie? Yeah, ST. Okay, UW is parallel to ST. That's the third side of that triangle. Okay, so UW is going to equal half the length of ST. All right, well, what's the length of ST? No one knows. We know one piece of ST. We know that from S to V is 10.2. So what's V to T going to be? It's going to be 10.2 as well. It has to be, because remember, V is a midpoint, right? This is a mid-segment, so V is a midpoint, so those are going to be equal. So the total there is 20.4.
Well, all these triangles are equilateral.
No, we're not told they're equilateral, so we can't assume that. Yeah, we can't assume that. Good question, though. Okay. So if ST is 20.4 in length, what can we do to find UW? Yeah, divide by 2, which is going to be what? 10.2. Okay, 10.2. So ST is equal to 20.4, and so we'll do 20.4 divided by 2, and that's going to be 10.2. So that's our length. Oh, that is too funny. Did anyone look at the work over here that they showed?
Yeah.
They're saying that ST is 10.2 units long, but you can see in the diagram here that's clearly not the way that they marked it, so I think there's an error in the picture there or something like that. So SU and UR, good question. We actually don't have enough information right now to say that that's going to be, that like this is 10.2 and this is 10.2. We can't say that just yet, okay? But we will come up with some more stuff here. So let's see here. We want to find, okay, so let's say, for example, here, UV, okay, that length is 5.6. So if I have UV here, how could I find RT? What could we do? 5.6 times 2. Okay, the length of this mid-segment here, this mid-segment is half the length of this. So if I want to find this length, I'll just take that 5.6 and multiply by 2. So RT, okay, is equal to 5.6 times 2, which is 11.2, I believe, when we do that math. Okay, so that length right there is 11.2. Kind of worked out there. Okay.
So like.
Question? Yep.
So the UW, like that part,
Mhm.
doesn't that like be right or something? Because like if you like kind of like do the V to W like a line divided.
Okay, like so this mid-segment right here, you're saying?
Yeah, and then wouldn't that kind of be the same thing as SV?
So let's see here. So you're saying U to W would be the same as S to V? Yeah, no, that's exactly right. It does match up. Yes, you actually can see here that when you draw in all three of the mid-segments, you create a triangle right here in the center that is congruent to this triangle, and this triangle. They're all congruent. So this triangle in the center here that's created from those three mid-segments is actually then congruent to this one, and this one. They all match up. And so, yeah, when we say that SV here is 10.2, okay, that matches up here to the UW 10.2, which then also matches up to the VT. You have to, like, rotate it some to get it to match up exactly right, but, yes, they're all these congruent triangles. There's 4 congruent triangles in there. Okay? Question? Okay, so anyway, so we want to find the measure now, last little thing here for this, we want to find the measure of angle SVU. So that's this angle right here. Okay? So ideas? Yeah, go for it, Corey. What do you say?
So you see how you have 41 right there? We
Yes.
Subtract that from 180 and divide it by 2.
So if we look here, angle U, okay, is an angle in this kind of like little mid-segment triangle right here that we have, right? Okay?
So would that be the angle bisector for like TUR?
T.
I mean SUR.
SUR. Well, so it's not quite a bisector because we have actually three angles here. So bisecting just cuts into two equal angles, okay? But there is a relationship here between this 41 and this angle right here, okay? There is a relationship there. Eli, what do you want to say? So, yes, okay, that's one way. That's a great argument, actually, right there, okay? So UW, we know, must be parallel to ST. 41 degrees is on, and then we can think of this UV as a transversal, right? So there's parallel lines, crossed by a transversal, so 41, and that must be 41 because they're alternate interior. Exactly right. Okay, so the measurement angle SVU, special victims unit, is 41 degrees. Okay. So does that make sense to you there, Corey, now? Do you see that?
Yeah, but how would you find then?
Other angles?
Yeah.
You don't have enough information. Yeah, that's a great question. You can't. Okay, in this case, we're not able to. Okay, we need one more angle, I think, to be able to figure out the rest of the triangle. So, okay. All right, cool. Let's try another one here. So let's skip down here to number 6. Okay, the your turn there. We'll do this one together because, again, that was only just one problem. So we'll try this one here on our own, too. Okay. Okay. So we've got a big triangle here, JKL. Okay, and we've got two midsegments drawn. There's a midsegment there. There's a midsegment there. Okay, so let's go about this. So we want to find. Let's find JL first. So here's JL, right there. Okay, so volunteer here. How can we go about finding this side? Yep.
JL is 78. That's 39.
Times 2. Yeah, exactly right. Yep, exactly right. So our midsegment here, PN, okay, is 39. So that's going to be twice 39 will give us the length of JL. So 39 times 2 equals JL, okay, which is 78. So JL equals 78. Very good, Corey. Exactly right. All right. So there's JL. Now let's talk about PM. All right. So Melissa, I'm going to go to you here. PM. What can we do here? PM is a mid-segment. How can we find that length? Yep, PM was 39, yep. So we want to find PM, though. So remember let me refresh your memory, let me help you out over here, because Corey, what he did is he saw, okay, when we wanted to find JL, he knew that JL was going to relate here to the PN. That's the mid-segment, okay, and the mid-segment here, twice that would give us this length. Okay, now we've got this long length, and I want to find the length of the mid-segment. So what should I do to this 95? Divide by what?
2.
Yeah, exactly right. We're going to go backwards now. We've got the full side length. We want to get the smaller length, so we divide it by 2. It's going to be exactly half. Yes. So PM is equal to 95 divided by 2, which is not going to be an even number. 47.5? Thank you. Okay, so there it is, 47.5. Well done. Good job, Melissa. Okay. Goodness, this is like not random at all.
Just use the RNG.
I did, and it's not working.
On your computer.
Oh, I could do that too, yeah. Okay, so let's look at one more here. We've got angle MLK, so let's see if I can find that here. So it's MLK, so I want this angle right there. Okay, let's go to Gabe. What do you say there, Gabe? Angle MLK, what's that going to have to be equal to? What's that measure going to be?
Wouldn't you have take 95 and 39 together?
So, well, now be careful here. 39, 95, those are measures of sides. We want the angle MLK here, so we want a degree measure here. Okay.
I know.
So if you're not sure, that's okay. You want me to move on to someone else? Okay, move on. That's okay. That's fine. Thank you for saying so. Let's go to Piper. What do you say here, Piper? What does angle MLK have to be? Any ideas? Yeah, it is. Okay, now how are you able to figure that out? Okay, how do you know these two angles are going to be congruent? You just know. You have the intuition, the geometric intuition. Okay, and that's okay. I mean, like, that's such a thing. That's a thing. I get what you're saying there. Alex, you want to try and explain?
I said 105 because, like, it has this thing that it was, like, parallel.
Okay,
Well,
so,
not parallel.
no, you're on the right track there with that, actually. Yes.
Dashes, so I automatically thought that it would be 105.
Okay, so let's go back to that idea about parallel, though. PM, right, this mid-segment has to be parallel to LK, right? That's a mid-segment. It's parallel to this third side here, right? Just like PN is parallel to JL, PM has to be parallel to LK. Now, we have two parallel lines right here, right, crossed by this transversal. What special angle pair are these two angles? Okay, so actually, aren't they on the same side of the, and they're not interior, so let me make it more obvious here. Hopefully I'll draw like the parallel lines in, and then here's our transversal. Okay, you see that now maybe a little bit better? So you got parallel lines right there, crossed by this transversal. If we know this angle right here is 105, what special angle pair? Corresponding. These are corresponding angles. They're in the same position. Alex, do you see that okay? They're in the same position. These are corresponding angles. Okay? If we were talking alternate interior, we'd be talking like this angle and this angle right here, or this angle right here and this angle right here, right? Those are alternate interior, but theirs are corresponding. So that makes 105.
Only know a vertical thing then too, and alternate interior.
Right, yeah. So we want to make sure we remember those special angle relationships because they show up quite often when we have parallel lines. Okay? Questions on any of that?
Oh, can we get started on that?
All right, so 1 second here. So I'd like you to take a look at number 8 and think about that. Take about like a minute or two. There's no numbers there, but I think you can still kind of figure it out. So take a look at number 8 real quick and think about what that says. It says, explain how the perimeter of triangle DEF, that's that smaller triangle there, how is that triangle's perimeter going to compare to that of triangle ABC? So I want you to just sit there and think about it real quick. You don't actually have to, there's no numbers, but you actually don't need the numbers. Okay, so just think about how those two things are going to be related there. Okay, so I'll give you like 30 seconds to think about that here, and we'll call us back together here. Okay, so how should those two perimeters be related? Okay, so yeah, okay, Corey basically said it right there, okay? The perimeter of triangle DEF should be exactly half that of triangle ABC. Now, Corey, how are you able to figure that out?
DE is parallel to AC and parallel to AB.
Okay, and then DF will be parallel to BC. And so DE is not only parallel to the side, but how does its length relate? Yeah, so DE is half of AC's length. AB, if you take half of that, gives you FE, and then FD is half of BC. So if we have half here, half here, half here, whatever, I messed it up, sorry, half here, half here, half here, all these sides are half these lengths. So the perimeter of this shape, whatever it is, half of that will be the perimeter of that shape. Okay? This triangle right here is exactly half the perimeter of this triangle. Okay? Notice, are there areas half? Are there areas going to be half? Is the area of this big triangle going to be half the area of this little triangle? Okay. What do you guys think? Is the area of this big triangle going to be half the area of this little triangle? And you can actually, so actually the answer here is it's not. But you can figure out what fraction the area will be. Yeah. What'd you say, Eric? 1/4. Okay. How'd you get that, Eric? How'd you know that the area of this small triangle here is going to be 1/4 the area of the big triangle? That's right. Okay. You see what he's saying here? This triangle in the center here that I'm asking about, the area, right? How many of these triangles are there? There's 4 of them that it takes to make up the big triangle. 4 of these little ones, right? 1, 2, 3, 4. Remember, I said they're all congruent. All 4 of these triangles make up the big triangle. So the area of this big triangle, okay, is 4 times the size of this smaller triangle right here. So the perimeters are half, but the area is 4 times, or 1/4. Okay, very interesting. Again, 1/2 the perimeter, but 1/4 the area. Okay, yeah, Al?
Wouldn't that really like a scale factor?
Yes, very good, exactly right. Yes, in fact, we're going to talk about that. So the scale factor in this case for a mid-segment, right, is 1/2. So, but yeah, exactly right. Very good. We'll see that later in the unit on similarity. Yeah.
Let's put down this here. Well, could you actually multiply the perimeter by 4?
So if you multiply, so here's what you got to be careful about, right? So for example, if I take this side, right, and you imagine multiplying it by 4, well, that would then, it would give me 1, 2 here, but then I would have 2 more that I wouldn't need for this side. You understand?
The whole perimeter.
The whole perimeter of what? Of this?
Yeah.
And multiply the perimeter by 4 to get the area of this? Or the perimeter, you're saying? So if we do that, so again, if I multiply this perimeter by 4, that means I'm taking this side, I'm going to multiply it by 4. I'm taking this side, multiplying it by 4. I'm taking this side and multiplying it by 4. You see the problem with that, though? If I have 4 of these, well, I only use up 2, and then I've got 4 of these, I'm going to use 2 there. I got 4 of these, I have 4 of these, but I only use 2 here and here. I got 4 of these, only 2 here, and I'm going to have some extras left over. So yeah, it's not times 4, just times 2. Just times 2. Okay? All right, so that's it. So here's what I'd like you guys to do, okay, for the remainder of class here. Your homework is going to be 6 through 15. Okay, I'd like you to try numbers 6 through 15 here. So on the page 400, 6 through 15. Okay, and yes, 15 has an A, B, C, D, E, F. This is not an April Fool's joke, okay, but you do have a very good amount of time here to get this done, okay? So you can get started on that here. I'm going to go grab your review so you guys can see.